Professor Zawole again. Today we're going to be going over another section of the West African Examination Council Senior Secondary School Certificate Examination, Mathematics for Liberian Schools. Today we'll be going over a subsection of algebraic processes, which is titled Algebraic Expressions. Under this section, we're going to cover two subsections. We're going to learn how to expand a binomial and factorize algebraic expressions. So these are the two subsections: expand binomials, and then factorize algebraic expressions. So one of the first things we want to go over is the basic binomial theorem. How do we expand a binomial? Well, let's look at the expansion of this. So basically, this is what we call the binomial theorem. It shows you how we can get the coefficients and the powers when a binomial is expanded. For example, a binomial a plus b to the 0 power, you know that anything raised to the power of 0 is 1. A plus b to the first power is just going to be that. And it shows you how when you raise a binomial to the power of 2, the coefficients are going to be 1, 2, and 1. And for the 3 and the 4. We can continue. We're going to go further down and show you the Pascal's triangle, which will help you to find the coefficients here. And we're going to also want you to observe the powers. So for example, the degree is 3. So the power of A is going to start with 3 and it's going to be decreasing as you go. And then the power of B will just be increasing. Now, I want to show you how we can get the coefficients using the Pascal's triangle. So recall, for the first row here is when we raise the power, say A plus B to the 0 power, that's just going to be 1. So our only coefficient will be 1. Next, when we raise A plus B to the first power, our coefficient is just going to be A plus B, so the coefficient will be 1, 1. Now, to get the second, which is basically A plus B squared, is you add these two, you write 1 at the end, and you add in the middle, you have a 2. We can do the same thing to get the third row, which is A plus B to the third power is going to be 1, 1. 1 plus 2 is 3, 2 plus 1 is 3. So this is how the Pascal triangle is built, and these values represent the coefficient when a binomial is raised to the appropriate power. When a binomial is raised to the second power, third power, fourth, fifth, and what? 6. Okay, good. So here we see the binomial theorem kind of stretched out. You see that the power of A will start with n and then begin to decrease, whereas the power of B will be introduced and then begin to increase. These coefficients can be computed, as you're going to see in the next section here. We can use this factorial combination of formula to find them, but we can also use the Pascal triangle to compute this. So another section that we'll be dealing with here is the concept of factoring a polynomial. And factoring a polynomial, the first step is to factor out the GCF if it is necessary, and then we look for other things like, do we have a trinomial, and seeing what forms of the trinomial we have to factor. So one of the most and basic kinds of factoring we're going to do will be factoring involving trinomial of the form x squared plus bx plus c. Now, if a trinomial of this form is factorable, then it's going to factor into something like this: x plus b times x plus q, where the product p q will give us c, the constant c, and the sum of p plus q will give us b. All right? So this is how we factor any kind of trinomial of this form if it is factorable. Not all trinomials are factorable. Okay? So this is trinomial of this form. So now the second kind of trinomial we have is one of the form ax squared plus bx plus c. So in this case, we see that the leading coefficient is now 1. is some real number represented here by a. Now there are numerous methods and techniques for factoring a polynomial of this form, a trinomial of this form. As we engage problems, we will introduce you to that. In fact, we will produce a video that will focus entirely on factoring these kind of trinomials shortly. Now, it's also good to look for some special factors, one of which is the difference of squares. So if we have a trinomial where the first term is the perfect square, the second term is the perfect square, and they can factor into a minus b, a plus b. Okay? A minus b, a plus b. So the next one that we have, and it's not so visible yet, is factoring perfect square trinomials. But basically what we have is that some trinomials are perfect squares, binomials. Well, from here we can see that this is basically factor into a plus b, or what? Squared. Okay, if we square a, we're going to get a squared. If we square b, we're going to get b squared. If we multiply a by b and double it, we get the middle term. That's a perfect square trinomial involving the sum. Likewise, we have the one involving the difference. Now, we also have sums and difference of cubes. Now, so for this, we have formulas that you have to be able to retain. So we say when a cubed plus b cubed are perfect, we have a cubed and b cubed. These are perfect cubes, then they can factor into one of these two forms. Watch what's going on. The sign here is the same as this. The sign here is going to be the opposite of this. This is always going to be positive, as you can see, positive. This is kind of the opposite of that. All right? So it's very important to remember this formula. There are many mnemonic strategies for retaining this formula. Again, we'll develop additional videos where we'll just actually focus on different techniques of factoring, and we'll share some of the mnemonics that you can use to be able to retain and recall this information. So here's our first problem. Instead, we should find the second term of this binomial. What we're going to do is that we'll expand the entire binomial just so that you can understand how we do it. So, and then from there you can factor, you can determine the second term. So like I said, we're going to expand the entire binomial. So we're going to, first of all, what we want to do is to identify the coefficients of this. So let's make a little Pascal triangle over here. Remember, it's 1, 1, 1, 2, 1, and this is for a plus b to the 0. This is for a plus b to the first power. This is for a plus b to the second. We need to go to a plus b to the fourth, and this will be 1, 3, 3, 1. That's a plus b to the third. And lastly, we have what we need. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1. So this is a plus b to the fourth. So let's set it up. So basically, our a in this problem is going to be 5x squared. Our b in this problem is going to be what? 3y. So this is how our answer should look like. It's going to look like a what? Q a to the fourth plus 4a cubed b plus 6 a squared b squared plus 4 a b cubed plus b to the fourth. So now I'm going to substitute. So remember that my a was basically 5x squared. So that has to be raised to the fourth power plus 4. My a again is 5x squared, and my b is 3y. I have a 6 here. My a is 5x squared. My b is 3y. I must square it plus 4. My a is 5x squared. My b is 3y, and this time 3y is cubed. Plus My b is 3y, and I must raise that to the fourth. Let's do some computation here quickly. 5 to the fourth power is going to be 625, because that's 5, and then x to the what? 8th. Plus, let's see how we can do this quickly. 5x squared, I forgot to put the cube over here. So that's going to be basically 5 cubed. That's going to be 125 times 5. 125 times 4. That's going to be about 600. Am I right? 125 times 4. That's going to be 500. 500 times 3. That's going to be 1,500. X to the 6y. That's our answer. Actually, that's what we are looking for. But like I said, that's going to be the second term. But I'm going to continue to do this. So then I have 5x squared squared. So 5 squared is 25. 25 times 6 is going to be 150. 150 times 9 is going to be, so let's see, 150 times 9, 150 times 9, that's going to be plus 1,350 x to the fourth y squared. And like initially I said I'm going to continue, but I think this is fine for now. We should be able, if I can just finish this. Now what we'll do, next one is going to be 3 cubed, that's 27. So we're going to multiply 27 by 5 and then by 4 to get 540 x to the 5th, x squared, sorry, and y cubed plus 3 to the power of 4, which is going to be 81 plus 81y to the fourth. Those we are right. So, but actually our answer for the second term is going to be 1,500 x to the 6y. Okay? So let's take on the second problem. Now, in this case, we're asked to find the middle term. So again, that's for number 2. We have 2x cubed minus y squared to the 6th. So first thing, let's see if we can build our Pascal triangle on this. And we could have also used the binomial theorem, which I know a lot of people struggle with. So I'm going to think the Pascal triangle is kind of easy to build and get our coefficient. And because we're not interested in finding everything here, we easily find the term that we're interested in. This is 5. This is going to be 10. 6 plus 4 is 10. That's going to be 5. And then 1. So this is x plus y to the first, to the 0. X plus y to the first. X plus y to the second. X plus y to the third. X plus y to the fourth. And this is going to be x plus y to the fifth. So now we have where we are looking for 1 plus 5 is going to be 6. 5 plus 10 is going to be 15. 10 plus 10 is going to be 20. 10 plus 5 is 15. 5 and 1 is 6, and then 1. So what's the middle term here? 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So it's going to be 20. So we'll be having some. So let's see how we write this out. So for this, we're going to start with, say if this was a plus b to the 6, let's write up this formula. We're going to have a to the 6th coefficient of 1 plus 6a to the 5th, b plus 15a to the 4th, b squared plus 20a to the 3rd, b to the 3rd. So that's what we are looking for. 1, 2, 3, 4. That's the middle term right here. So let's go and do 20a cubed b cubed. Remember, our a is actually 2x cubed. Our b is actually y squared. And so, and that's negative. So let's put it in and see what we have here. It's going to be what? 20. A is 2x cubed, and our B is y squared cubed. Okay? So we got to be very careful here how we do this. So we're going to have 20 times 2 cubed is going to be 8. X to the 3 times 3 is what? 9. Y. So we're going to have y to the negative, y to the 6. And this is going to be negative. So our answer here will be 20. Let's do the expansion here. 20 times 8 is going to be negative 160 x to the n y to the 6. See, how do you check up the sign? You got to start with positive, negative, positive, negative. That's one way to figure the sign. So it'll alternate like that. So let's see now, we can move to the next problem. So for this problem, we are supposed to factor. So factorize completely. One of the things we want to look for first is the greatest common factor. Looking at problem number 3, we see that n is everywhere. So that is a common factor, and we can take that out. So like I said, we see that n is here, n is here, n is here. But the highest power of n that is shared is actually n. So we can factor out n from here. That means we'll be left with m squared minus 2m. We take an n from here, so we're going to be left with just an n plus what? N what? Squared. Now, this is a trinomial in here, and from what I'm seeing, it's a perfect square trinomial. So look, what do we have here? M minus what? N squared. We can test that to see that m minus n times m minus n will be m squared minus mn minus mn plus n squared. So you end up with m squared minus 2mn plus n squared. Now, because I could easily recognize that this was a perfect square trinomial, I could quickly get to my answer. So let's move on to problem number 4. So number 4, again, there are things that you can look up into that problem and figure out that it contains the difference of squares. So, well, when we look at number 4, it appears complicated, but a little rearrangement can make things much more understandable. So, I can see here that this is a difference of 2 squared. It's not so clear, but let's try this. So I'm going to write y squared. I'm going to put a minus here, and I'm going to bring the rest of these terms in here. So if I'm taking this as x squared, if I take this minus up here, it's going to be positive x squared. This positive, because of this minus, will be minus 2x, and this minus is going to be positive what? 1, which is, I haven't changed anything. If I reapply my negative, I go back to what I had. Now, by doing this, I can then factor this one. I can see that this is a perfect square trinomial with factors x minus 1 squared. So what I have now is a difference of 2 squared. This is a perfect square. The square root of y squared is y. This is a perfect square. The square root of parenthesis x minus 1 squared is x minus 1. So this is a difference of squares. So I have y minus whatever it is here. And then again, y, square root of this, minus here, so it's going to be plus whatever I have here. So then we can break up, we can drop the negative, we can put it negative x, distribute the negative, it's going to be plus 1, y plus x minus 1. So then we are done. Okay? Let's move on to number 5. So for number 5, we have a situation of the difference of cube. If we look at that carefully, we have x cubed minus y to the 6. Understand, for finding the powers, or finding the roots of exponents, variable exponents, it's not like finding, say, the square root of 3 or square root of 6. So 3 as a real number doesn't have a perfect cube root, but to find the root of x cubed, we basically divide the power by 3. So is this divisible by 3? Yes. Is this divisible by 3? Yes. So what we have here is that this is a case of a cubed minus b cubed, which factors into a minus b times a squared. Remember the opposite? AB, always what? Positive at the end. So basically, let's go here. What's the cube root of this? We can get this by dividing the power of 3 by 3. So we have x minus, we can get the cube root of y to the 6 by dividing that by 2. We have what? Y squared. Once we have this, to have this n, we're going to square this. X times, that's going to be x squared. Opposite is going to be plus the product of this, which is x, y squared, and then plus y squared squared, which is y to the 4th power. So we're done with number 5. Let's see if we can do number 6. So for number 6, well, we see that, first of all, let's see. We see that we have 5a cubed plus 375b cubed. Well, for number 6, we are seeing cubes. So we are thinking about, it is a plus. So we're thinking about the sums of cubes, a cubed plus b cubed. But the problem we have is this is not a perfect cube. Likewise this. So let's see if we can factor out the common factor, which I think is 5. A cubed plus, if we divide 625 by 5, we get like 1. That's going to be 12. That's going to be 2. That's going to be 5 into 25. That's 5. That's going to be 125b cubed. Now, we know that 125 is a perfect cube. So, well, we have a situation of the sums of cubes, which factors into a plus b, a squared minus ab plus b squared. So, well, the cube root of a cubed is a, plus the cube root of 125 is 5, the cube root of b cubed is b. And to find here, we're going to square this. It's going to be what? A squared. Find the product of this minus 5ab, then plus square 5b, which is give us what? 25 what? B squared. So we are done. Again, thank you for listening. This has been a production of the Foundation for Equity and Excellence in Education in Liberia, a foundation committed to providing quality content instruction for all Liberian children. We are on the web at www.vliberia.org. You can also follow us on Twitter, visit us, and like us on Facebook. Thank you. We hope you can go online and do additional practice. Wish you all luck as you prepare for your West African Examination Council Senior High School Certificate Mathematics exam. Thank you.